Hi, my name is Aiden Riley, and this is Lab 4, Magnetic Field of a Bar Magnet. The purpose of the experiment was to observe magnetic fields through the visual representation of the relationship between distance and magnetic fields, and through this visualization and the Biot-Savart law, find the magnetic moment of a bar magnet. In the end, we got the result that it was 1,615 amperes times meters squared, and n equals negative 2.48. Our equations, the Biot-Savart law, and the distance dependence of a bar magnet. So first, our model assumption, the bar magnet acted in accordance to the Biot-Savart law, specifically with the assumption that the bar magnet was a magnetic dipole, which you can see that kind of model assumption visually in the back. So the experiment and the setup, we were just trying to find B net through a couple of measurements. So the first thing was the setup, which was finding where the magnetometer was, which was basically rotating the phone and moving it so that we could find the 0 and the x and the y axis, and then marking with the tape accordingly. The system in the experiment was the bar magnet, and the surroundings was everything else. Our initial conditions, there's the bar magnet at the end of the stick, the magnetometer was turned on the phone, and the phone was facing magnetic north. The distance magnetic strength relationship was the first thing we've tried to find. So we just measured the distance at which readings of 20, 70, 120, 170, and 220 microtesla were read. We then did off-axis measurements for the experimental B net value. We moved a distance d perp, where d perp was where 100 microtesla was read, and then we moved another d perp in the y-axis, and then got a distance d, which was calculated here, and then gave us a total B net. Some observations. As the magnet approaches the phone's location, the field strength increases, with far distance making the magnet's reading near zero in terms of magnetic field strength. And second, the phone's position matters since the magnetometer is in a particular location, and having the magnetometer off axis from the magnet results in non-zero field readings in more than one axis. So some calculations from the experiment. The distance dependence equation, this is what we got from putting our results into the Excel spreadsheet. Then we realized that the slope was equal to the n value. The plus y in the y equals mx, or the plus b in the y equals mx plus b was the ln of k, which then got us k. Eventually, we manipulated the Biot-Savart law to find what the magnetic dipole was, and plugging in, we got 1,615 amperes times meters squared. So the start of the GlowScript code was basically setting up the strength of the magnet, setting up a magnetic dipole, doing arrow scaling and distance, getting the axes and the perpendicular axes set up, and getting some of our arrows for the magnetic field set up. Next was setting up some arrows for the visual representation, and then finishing off by putting what dperp actually was in the terms of the experiment, and then finishing up some visualization features. The results, it looks something like this. Uh, we got b-axis 1, 2, all of the perps, the distance d that was calculated, and then finally b net, but in terms of a vector. We then could use this to compare the coding versus our experimental results. We got about a 200% difference. Um, Most likely the error was human side. I would say that we did use quite a couple of magnets stacked on top of each other, which did give us a very strong magnetic reading. And due to that, the repeated exposure of the phone to the magnet itself could have skewed the numbers a lot. Additionally, our setup may have not have been exactly magnetic north, resulting in more skewed numbers. Um, which the reason that's important, and also the first what if question, is basically if you didn't compensate for magnetic north, um, you wouldn't be compensating for Earth's magnetic field. So that would make the results inaccurate because the Earth's magnetic field is relevant, though its strength is relevant to the total B net. So finding the B net of the magnet itself would be a lot different. And if we did try to account for it, it would also be a lot harder because since it's not purely in one axis, it would mess up every number and would make it so that the B net would have to then be, or we would have to get to B net, then accommodate for the Earth's magnetic field. Finally, if you were to stick two identical magnets, basically it would just double the magnitude of all of our results, but the directions wouldn't change. And yeah, that would be the results of this lab.